All right, we're live. GM, everybody. Welcome to what's going to be another great DevNTell. So if you didn't know, DevNTell is a 30-minute window for builders to showcase something they're passionate about or been working on in Web3. It's going to be an awesome project we've been working on, demonstrating unit testing best practices, automation goodies, smart contracts, how to structure a project, etc. Basically, if you've got a passion for something, it's your opportunity to share it with the Web3 community. And today, I'm ecstatic to have Ben Weinberg from Axelar Network. Welcome, Ben. How are you doing?
Thanks for having me. I'm doing great.
Excellent. Yeah, I guess before we get going to the meat of the content, did you want to give a brief introduction about yourself?
Yeah, sounds good. Maybe, can I share my screen?
Yes, you can. Yep.
Sounds good. Share screen, entire screen. Okay, can you guys see my screen?
Now we can.
Mirror,
Yep.
death mirror there.
Yep. There you go.
Nice. All right, so I'll get into it if it's cool with you.
Do it.
So thanks everyone for joining. My name is Ben Weinberg. I'm a developer advocate with the Axelar team, and just a brief overview of what we're going to be talking about for today. We're going to go over the need for interchain, how we got here, and the problem with bridges. So what Axelar is it is an interoperability solution, basically to allow users to send messages and assets between different blockchains. So we're going to start off with a brief history and like go over how we got here, why this matters. We're then going to get into the Axelar network and look at what is it, what does it do, what's unique about it. And then we're going to get into a really cool feature called general message passing, otherwise known as GMP, which I'm really excited to share with you guys. And then we're gonna end off with Axelar in the wild, who's actually using us, and show off some stats, like what are the numbers of people using Axelar, and yeah, let's get right to it. So a bit about myself. I first got into the blockchain space in late 2017, and at the time, for me, I'd like to connect with people by going to meetups. That was kind of my grand strategy of how to get into the space and like see what projects are popping and who's doing what. And at the time, you go to these events and everyone seems to know a lot more than you. And many people were promoting different projects which they were invested in. There was, of course, Ethereum at the time, which was the front runner that most people were invested in. But there were other projects such as Neo, which was branded as like the Chinese response to Ethereum. There was EOS branded as like Ethereum on steroids because it was faster and cheaper. There was Tron, there was IOTA, and many of these projects were branded as like Ethereum killers. In other words, that this project will be the project to kill Ethereum and be the be all end all of blockchains. And this mentality that people had at the time was that of chain maximalism. In other words, one chain to rule them all. And I think that it's safe to say now, end of 2023, looking back, is that this idea of chain maximalism is wrong. We never actually saw one blockchain to rule them all. Rather, what we saw was the increase in the number of blockchains that exist. And I'm going to show you a brief video I took a few months ago now from a website called chainlist.org. And what chainlist.org does is it shows you a list of many of the blockchains that exist today. And I say many, not all, because it's actually impossible to say for certain how many blockchains exist. But what you can see here on chainlist.org is that there's hundreds, if not thousands, of blockchains that already exist. And that number is only going to continue to grow. And we've seen different types of blockchains. We've seen the rise of layer 2s. People are talking about layer 3s now. We've seen blockchains that are more optimized towards speed, blockchains that are optimized towards privacy. We've seen the rise of app chains, which are blockchains that are geared towards one specific application. I think you guys get the point here. Any questions so far? No, I'll keep going here.
None yet.
And what we've seen with the rise of all these different blockchains is that there is a need for interoperability between these chains. For us to be successful as an ecosystem, we know that chain maximalism won't happen. There won't be one blockchain to rule them all, but we need a way to actually connect these different blockchains. And this is not a new question. People have known this for years already. And what we saw was the rise of pairwise bridges. In other words, many of these bridges were using assets such as WETH or WBTC, and these are wrapped assets, which basically derive the token. So one WETH is equal to one ETH in value, one WBTC is equal to one Bitcoin in value. And you could basically use these tokenized versions of native assets on different chains. And this is great, and it worked. The problem with many of these bridges is that they were using multi-sig contracts. And over the past few years, we've seen the dangers of multi-sig contracts with powering pairwise bridges, or I should say securing pairwise bridges. These are some headlines I've taken over the past few years of hacks that have occurred on bridges. The most famous one being the one on the top left corner, the Rona network bridge hack that happened for about $625 million. Several other ones here. And there's another interesting article from a firm called Chain Analysis. They estimated that in 2022, $2 billion worth of funds, which is about 69% of total funds stolen in all of Web3, were attacks on these bridges. So if we pause here and let's look at what we've already talked about. The number of blockchains is rising. We need interoperability. Chain maximalism is wrong, but we as an ecosystem have a lot of improving to do in the way we conduct interoperability between blockchains. Everyone with me so far? And this, at this point, is where Axelar comes in. So what is Axelar? Axelar is a blockchain that connects blockchains, enabling universal Web3 interoperability. That's in its simplest terms what Axelar is. And this is a mouthful and a bit jargony, so let's break down this definition a bit here. So if we look at this diagram of the Axelar network, we can see it at a 50,000 foot view. Axelar operates a hub and spoke model, which means that these blockchains connect or transact through Axelar to get to another blockchain. And I want to focus right now on these last three words from this previous definition: universal Web3 interoperability. What do I mean by that? Well, let's look at some of these protocols that are actually connecting to Axelar or via Axelar. If you look at the top left here, you can see Ethereum, Phantom, Polygon, Avalanche. These are examples of blockchains that are running the Ethereum virtual machine that are powered by proof of stake. We also have projects such as Osmosis, Juno, the Cosmos Hub, Evmos. These are projects built in the Cosmos ecosystem. We even have projects like Arbitrum. We have Linea, Base, though I don't think those last two are on this diagram, but Linea, Arbitrum, and Base are examples of layer 2s. And you can see what I mean here by universal Web3 interoperability. It doesn't matter what virtual machine your chain is running. It doesn't matter what consensus mechanism your chain is running. Axelar can connect any different type of blockchain, universal Web3 interoperability. And right out of the box, when you connect your blockchain to Axelar, there are two major improvements which you get just by the nature of the design of Axelar. And those are scalability improvements and security improvements, okay? So let's look at scalability improvements first. Imagine a scenario where we have three blockchains. Let's call them Ethereum, BNB, and Polygon, okay? And now I want to connect these three blockchains to each other. You can just count the numbers here. If I want to connect Ethereum to BNB to Polygon, and each to in every to every way, or any to any way, then you need 6 bridges to connect each of those blockchains to each other. Now imagine I want to add one more blockchain, let's say Avalanche. Now to connect all these blockchains to each other, that number goes to 9 bridges for just one more blockchain that you added. Now imagine if we want to connect every blockchain that exists, hundreds or thousands of blockchains that exist, how many bridges we'll need to connect each of those blockchains. So by using a hub and spoke model, all you need is just one connection to Axelar, and by extension, you're now connected to every single blockchain that is also connected to Axelar. And I like to think of this in my head as pairwise bridges are more like train tracks. You can go from point A to point B, and that's it. But whereas with the Axelar design, it's more like an airport. You just need that one connection to Axelar. In other words, you need like one airport in your city, and you can now, in theory, get to any other city in the world that also has an airport. So in terms of the way this design scales, it's much more scalable than having just pairwise bridges. The next major improvement which Axelar brings out of the box, in addition to scalability improvements, is security improvements, okay? So if we go back to this definition, we talked about universal Web3 interoperability. Let's look at this first sentence, or this first line. Axelar is a blockchain that connects blockchains. Now, what does that mean? Well, Axelar is a blockchain that is built on top of the Cosmos SDK. It currently has 75 validators running a delegated proof of stake consensus mechanism. These are some of the validators that are maintaining the Axelar blockchain. Anyone here in the Cosmos ecosystem might be familiar with some of these validators. There are well-known validators that are maintaining many other Cosmos blockchains in addition to just Axelar. So these are like Figment, Informal Systems, Pokachoo. And you can see here, having an actual blockchain that handles the interoperability layer of Web3 is a tremendous step up from just having like a 3 of 4 multisig, which you're relying on for security. So scalability and security improvements right out of the box are what you get when you use Axelar for interoperability. But I want to talk about a very, very exciting feature which Axelar brings. If you remember what we talked about in the early days of bridging, what you can do is actually use wrapped assets to interact with different blockchains. And this is really, really cool using wrapped assets, but we want to do a lot more than just use wrapped assets, and that's the be-all, end-all of interoperability. And that's where general message passing comes in. So what is general message passing, for those who haven't heard? It's, well, exactly like it sounds. It's the ability to send messages from one blockchain to another blockchain, okay? So you can see here a very simple example, myself on Ethereum and myself on Avalanche. And in the first message, I am saying like, hey, Wagny, like, are we going to make it in this crazy ecosystem that we find ourselves in? And then Avalanche back to Ethereum, I'm sending a message saying like, hey, Safeman 5 Bored Apes. And what I'm trying to show you here is that in addition to sending like silly little hello world messages like I'm sending on this top example here, what you can actually do is send function calls from one blockchain to another. You can send data from one blockchain to another that you could use in a function call on another blockchain. And that is true interoperability. It's the ability to actually interact with contracts on different blockchains as easily as you could interact with them on your own blockchain. I'm going to stop here for any questions that people might have.
Yeah, gang, be sure to ask any questions you may have in the comments, and I will bring them up on the screen here. And I guess one question from me before we get you continue on.
Yes.
Why Cosmos? Why Cosmos over any other chain to act as the foundation on Axelar?
Yeah, Cosmos was a very easy way to actually develop the Axelar blockchain in itself. So there are other ecosystems there to develop app chains, but I think Cosmos was just a very simple way to develop an actual blockchain to handle the security of the interoperability layer. Again, the key feature which Axelar has for security is the fact that Axelar actually is a blockchain. So it allows for the most decentralized, secure approach to actually sending or to handling interoperability between different blockchains. And Cosmos just presented itself as an easy way to do that.
Awesome, excellent. No other questions thus far, but I'll let you know if anything comes up.
Awesome. So just to recap where we were talking about general message passing. It's the ability to actually send data between blockchains. So I want to go into this a bit deeper, and then we're actually going to step through a brief code example with whatever time we have left. So the way this works under the hood, let's say I want to send an ERC20 token and a message from Avalanche to Polygon. Okay, so you have a smart contract which you have deployed on 2 blockchains, Avalanche and Polygon. And now what you have to do is your contract could be a game, it could be a DeFi protocol, it could be anything. But what you have to do to actually trigger that interchain message from Avalanche to Polygon is import a service called the gateway. The gateway is a contract which Axelar has deployed on every different blockchain which is connected to Axelar. So you have to import that gateway. And then the gateway exposes several different functions. One of those functions is called contract with token. So let's say you have your contract, you import the gateway, and then you call this function. This now triggers a transaction which basically allows the gateway to emit an event. The event is then submitted via a relayer to the Axelar network. The Axelar network, which remember, this X right here is an actual blockchain. So it's maintained by 75 validators. And those validators will basically come to consensus about this message. Like, hey, did Ben actually send this message from Avalanche, and is it actually going to Polygon? If yes, then we notify the gateway on the destination chain at this point on Polygon that like, yes, Ben actually did send this message. We are confirming that we're good to go. And then the gateway, via something called a relayer, will call this execute with token function, which we will have written on our smart contract on our destination chain. And then in the execute with token function, we can do any bit of logic which we want with that data. And I know that was a lot, and we will actually go through a code example so you can see all this in action step by step. We'll break it down very, very clearly. But one more time, just before we get into the code, our contract is deployed on Avalanche and on Polygon. The contract on Avalanche imports the gateway. It executes with this call contract with token function, which is defined on the gateway. The gateway emits an event. The event goes to the Axelar network. It comes to consensus about the message that was sent. It notifies the gateway on the destination chain, like, yes, this message was sent. And then it calls the execute with token function, which we will have implemented on our contract. So let's actually step through this. Can you guys see? Yeah.
We do have a couple questions. Did you want to save them for the end or go through the?
Oh no, let's go through it now while it's relevant.
Sure. So one here, Nikitas asks, is Axelar centralized or is it decentralized?
Yeah. So remember what I was saying before, that Axelar is a blockchain of blockchains with 75 validators. So it's as decentralized as an interoperability solution as you can get, because these are 75 validators. It's permissionless. We don't control like who's going to be a validator, who's not going to be a validator. Anyone can go and stake a bunch of AXL token, and if you're one of the top 75 validators, then you will actually be a validator who's maintaining this network. We plan on increasing that number from 75 validators to much more. For now, that's what we're at. But compared to other interoperability solutions, it's by far the most decentralized solution to conducting interoperability.
Sweet. Another question here. Vasilika asks, what blockchains are harder to connect than others? I guess, is there a certain type of blockchain that's harder to integrate with Axelar than another?
Yeah, that's a great question. It's not a question for me, unfortunately. I have not connected blockchains to Axelar. I know that we're working on many other blockchains, including hopefully Solana coming out soon. But actually, that is a good segue for a new feature that's coming out very soon. And I'll talk about that very briefly before we get into the code example. And it's called the Axelar Virtual Machine. So right now we have 53 blockchains that are connected to Axelar. This is the most of any interoperability solution. And the thing is, right now, every new chain that is connected to Axelar actually has to go through the Axelar team to actually onboard that chain. The Axelar Virtual Machine changes that. It allows teams to actually connect their blockchain to the Axelar ecosystem themselves. So right now, I think that's scheduled to still launch before the end of the year, the Axelar Virtual Machine. But that is kind of our holy grail of interoperability. It's the idea that anyone can connect their own chain, and that's how we get from 53 blockchains that are connected to hundreds or hopefully thousands of blockchains connected via Axelar someday.
Interesting. Yeah. One last one, I think it's almost similar to Vasilika's, is do you face any differences when connecting a proof of stake chain versus a proof of work chain?
Good question. Again, I have not personally been involved in the process of connecting chains. I don't think we have any proof of work chains connected right now. Most of our chains that are connected are either with the proof of stake consensus mechanism or that are Cosmos chains with Comet BFT, or formerly known as Tendermint.
Sweet. Yeah, all good. And great questions, gang. Keep them coming. In the meantime, let's get into the code here.
Yeah, awesome. And for the record, continue asking questions. Feel free to cut me off at any point. I want to try to keep this as informal as possible and as helpful as possible. So what we're going to try to do here in this contract, and I just want to refresh you guys on this chart right here. We're going to actually be implementing a contract which will go through the steps that we just outlined of a protocol or a smart contract which will send a token and a message via the gateway contract, or with the gateway contract via the Axelar network to our smart contract, which will be deployed on another blockchain. And remember these two key functions: call contract with token and execute with token. We're going to be using both of these. So first off, can you guys see my code, or should I make it bigger?
Sorry, it's legible to me. I think you're good.
Okay.
But crowd, if it's too small, let us know, please.
Sounds good. For time's sake, I'm going to be flipping through branches to write this step by step. Otherwise, this will be a bit long. So I'm going to go to step 1. where we are going to import several services that we will be needing. The first is in the ERC20 interface, which we'll obviously need to send the token from one blockchain to the other. Next is
Sorry,
the
Ben.
Axelar
Could you make
Yeah.
it a teensy bit bigger?
Yes.
Sorry about that. Yep.
Better or a bit bigger?
I think that's good. I think that should be good.
Good.
Yeah.
Sounds good. Yeah, so we import the ERC20 interface, we import the Axelar executable, which I will come back to this import in a bit. We import the Axelar gateway interface. Remember the gateway that is, let me flip this so you guys can see it, sorry. The gateway interface, that is this contract, which I was referencing here in the diagram. So we import this interface. We then import the Axelar gas service, which I have not talked about yet, and I'm gonna get into now quickly. The gas service is basically a tool which the Axelar team makes available for you to actually have an easier experience sending an interchain transaction. So if we think about it, if we want to send a transaction from, let's say, Polygon to Ethereum via Axelar, that means you'll need 3 tokens. You need Matic for Polygon, you need AXL, which is the token for Axelar, because remember, Axelar is a blockchain, so gas needs to be paid on it as well. And third, you'll need Ether, the token of the destination chain, which in this example is Ethereum. Now, I don't know about you guys, but I don't want to have to hold 3 different tokens each time I want to send an interchain transaction. So what the Axelar gas service does is it extracts that difficulty. It basically says you only need to pay the interchain transaction in the token of the source chain. So in the example of sending a message from Polygon to Ethereum, all I need is Matic. I just pay Matic to the gas service, and it handles actually paying the gas on the Axelar blockchain for us and on the destination chain on Ethereum. That doesn't mean we actually get the payment for free. The money still comes out of our pocket, but we pay it in the form of the source chain. So that is the gas service. So let me go to step 2, actually start writing this out. So the first thing we do is write out our constructor function, which we're going to pass in the address of our gateway and our gas service. Remember, these are contracts which are deployed by the Axelar team, which we will need to actually interact with the Axelar network. We pass in the address of the gateway to the Axelar executable. We then pass in the address of the gas service to this public variable right here on line 11. Step 3 is where it starts to get interesting. We have our first function called send to many. And these inline comments here are just to help a bit, but I will speak about it myself. This is a function which we're defining, which we're going to actually use to send an ERC20 token and a message from one blockchain to the other. So it takes 5 parameters. It takes, hey, what is the name of the destination chain? Like, where is this going to? What is the address on the destination chain that we're going to? So like we're sending to Ethereum, let's say. Well, once we get to Ethereum, where are we going to in Ethereum? Like what address are we going to be interacting with? So that's the second parameter. The destination addresses, this is a third parameter, which I promise I will come back to. Don't worry about it for now. And the last 2 parameters are relevant to the token which we're sending. So what is the symbol of the ERC20 token that we're sending? And what is the amount, like how many tokens are we sending? Is that clear, these 5 parameters? So destination chain, the address of the destination chain, a mysterious third parameter, which I'll get to, the symbol of the token, and the amount of the token. I'll go to step 4 in the meantime. So let's actually start writing out this logic. The first thing we want to do is a simple require statement. We say like, hey, make sure that some tokens are sent along with this contract, a message value of greater than 0, which we will eventually use to pay the gas service. If we don't send any message value, revert, because you have not, you will not be able to pay the gas service. Next thing we want to do is with our friendly gateway contract, remember that we're using up here, we're passing in. We will pass in the symbol of the token that we're going to be sending, and the gateway contract will return an address of that token. We're going to need that address of the ERC20 token to actually interact with it. Now with the address of that token, we're going to be doing some standard ERC20 functionality. We're going to transfer the tokens from our wallet to this contract, and then we're going to approve the gateway to spend the tokens on our behalf. And then we're going to encode this third parameter, which I promised I would talk about. So remember what we're trying to do here. We're sending this ERC20 token from one blockchain to another, but what we're also doing is sending this message. For example, WAGME. We're sending a message from one blockchain to the other. Now, to send that message from one blockchain to another, there's this very specific data type which it needs to be at, and that is bytes. So notice this third parameter is an array of addresses. So we're going to be encoding that into type bytes so we can actually send that message, this array of addresses, across Axelar to our destination chain. Step 5 is where we actually now interact with with Axelar services. The first one is this gas service, remember, which we passed in earlier. And the gas service is going to be exposing this function called pay native gas for contract call with token. And basically what this function does is it's going to allow us to send in a message value, send in our native token, and then basically tell the gas service like which blockchain will we be needing gas for? Where do you need to pay the token to? And then our final parameter here, our very important parameter, is message sender. So if, let's say, we have a transaction which costs half an ETH, but we send in 1 ETH to the gas service, then it will refund us the difference. So this is basically saying like, hey, where's the refund supposed to be going to? And these other parameters here are specifying like the chain, the destination chain, like where's the destination chain? So which chain will we need in gas payment for? And then our other GMP related functionality. So our destination contract address, our message, our symbol of the ERC20 token, and the amount. Then we will actually be interacting with our gateway contract with the call contract with token function. Remember, that is the function which I pointed out here on our diagram. So our call contract with token will require the same parameters which we just passed in before. So the name of the chain where we're going to, the address on the chain where we're going to, what is the GMP message that we're actually sending? So our encoded recipient address is here. That is our message that we're sending, the symbol of the token, and the amount of the token. So if we pause right here and we actually call this function, we will now successfully pay gas to our gas service, and then with our gateway contract actually trigger a transaction that will go to Axelar and then come out the other side on a new blockchain. So that's great. We've done this first half, and I promise the second half will be faster. We have to implement one more function, because once we get to that to the destination chain, well, what do? Well, what's going to be called is this execute with token function. That is this function here on the other side. Okay. And once we get in our execute with token function, we're going to have, step 7, where is it? We're going to have to implement some logic. So the only parameter I want you guys to focus on right now for here is our payload. And what the payload is this message that we sent from one blockchain to the other. It's going to be our list of addresses. So we want to decode that list of addresses. So we decode the payload, which is of type bytes. So now we have a list of addresses. Remember, that list of addresses is relevant to this list of addresses that we passed in. It's the same data that's just on the other side now. We then grab our token address of the token that was sent from one blockchain to the other. We then want to run some very basic functionality. So imagine we send 6 tokens, 6 USDC from chain A to chain B, and we sent 3 addresses in that list of addresses. And now let's say we want to divide up those 6 tokens and send it to those 3 addresses. So now we have 2 tokens that are going to each address. And now we simply loop over that list of addresses and transfer the tokens. And that is it. That will allow us to actually, in a very, very simple contract, send tokens from chain A to chain B. With those tokens that were sent, we also send a list of addresses. Then on our execute with token function, we decode that message. So now we have our list of addresses again. We then divide up the tokens between those addresses on a different blockchain, keep that in mind, and we send those tokens evenly. Any questions so far before I run this? I know we're short on time here.
There is a question, but let's finish this one off, and then we'll get to it.
Yeah, sounds good. So I'm going to run our deploy script to actually, let me go back to the main branch. The deploy script is basically deploying this contract. Let me zoom out a bit. Is deploying this GMP distribution contract on 2 different blockchains. Okay. Now, hopefully it goes fast. There we go. So we've deployed it on Polygon at this address. And it should also, I think, be deploying it on Phantom. Now we're going to use our hard hat console to interact with this contract GMP distribution live on Polygon. So I use our Ethers factory. I pass in this address that we just deployed to. So now we actually have this contract live on the Polygon blockchain, and we can now actually interact with it. So which function do we want to interact with? We want to do the send to many function. So let's pass in the parameters which this function needs. It needs the destination chain. So let's say Phantom. It needs the destination contract address. So that is this contract, which we deployed on Phantom. It needs a list of addresses, which will be our GMP message. I have this saved here from before. So we now pass in this array of 3 addresses. It needs the symbol of the token that we're sending, AUSDC, and how many tokens do we want to send? Let's say 6 million, or 6, but it's USDC, so it's 6 decimal points. And then the last thing we need to do is pass in some gas, or it will revert as per our require statement. So let me pass that in here. And now, once we press enter here, it executed. And I wish I had more time to show this off, but we will actually be using Axelar scan to track this transaction. So I can pass in that hash, which was just spat out to us, and you will be able to actually see this transaction going through Axelar scan. Cool. I did not pay enough gas. I could actually do that here directly via Axelar scan. Should pop up a transaction. I confirm it, and now gas is actually being topped off here. So for time's sake, we're not going to wait for this transaction to get through. I want to show you what a complete transaction looks like. You see the transaction was sent from Polygon to Phantom. You can see all the steps that have taken place to send the transaction, of paying the gas, confirming the transaction on the Axelar blockchain, and then eventually executing it on the destination chain. From Axelar scan, I can actually click here, and it takes me to the native blockchain which the transaction executed on. So for example, I'm sending from Polygon, I can press to here and it'll take me right to Mumbai. And I can see this transaction being executed on Mumbai. And I can see on the destination chain on Phantom, we received those 6 tokens and sent 2 of them to each of those 3 addresses that we sent in. So that is an example of a message and tokens being sent through Axelar from one blockchain to the other. Yeah, any questions on that?
That was pretty neat, man. I guess one good tangent question here, just on that. You mentioned that the gateway is a smart contract deployed on all blockchains within the Axelar network. How is a gateway added to a network that doesn't support smart contracts, for example, Bitcoin?
Yeah, we're not connected with Bitcoin right now. I'm not sure how that would work in the case of Bitcoin, but right now we're with well, I'll stick to EVM right now. All the EVM chains that we're on actually do support smart contracts. There are other Cosmos chains that we're connected to that some that support Cosmos, some that don't. It's a bit different in the Cosmos ecosystem. I'm going to stick just to EVM for now. All the EVM chains that we are on support smart contracts.
Sweet. And I suppose adding support is basically a internal process within Axelar to onboard a new chain onto the
yes,
hub,
until
right?
what I was talking about before, the Axelar virtual machine is rolled out. We're still onboarding each new chain ourselves.
Cool. I guess yeah, unfortunately we are close to time here. One question I want to ask you that I didn't get a chance to mention in the beginning is how did you end up with Axelar? I know you mentioned that interesting story that has developer down. I want to get that in here.
Yeah, so I kind of went into the talk a bit fast for time's sake, but it really is a special talk for me giving this one at Developer DAO. I actually was able to get into Axelar largely because of Developer DAO. Last year when Consensus Conference happened in Austin, I was able to score tickets to that conference through through Developer DAO at that conference where I connected with my now manager there. So that really kicked off the process for me joining Axelar. I really owe a lot to Developer DAO, so it's a big moment for me to now be speaking with Developer DAO on behalf of Axelar.
Yeah, that's an awesome story, man. And yeah, sometimes you never know. You just go through a conference or you just participate in the space and you never know what'll happen. But in this case, the best possible outcome happened. So I'm really glad to hear that and have you on here today as well to share Axelar and your experience with us. I guess just before we leave off here, what's the best way for people to get in touch with you or Axelar Network if they're
Yes.
interested in starting playing around?
Yes. So I didn't get a chance to go through all the slides here. These are some QR codes I want to leave for you guys open here. I'll leave them for briefly. On the left is QR code for a list of videos that we have. Just going through like the example I just gave, as well as other simple examples using Axelar. On the right is a link to a really awesome GitHub repository that we have, showing off examples of actually using Axelar. Some of them even have front ends wired up to that. So I highly encourage everyone to check both of these out, both the YouTube tutorials on the left and the GitHub repository on the right. For me personally, you can email me, ben@axelar.network. You can message me on LinkedIn, Facebook. Yeah, any way possible. Twitter. Um, I'm super happy to connect, even if it's like a year from now. Don't ever hesitate reaching out. I'm always happy to chat about this stuff. Yeah,
Excellent. And yeah, gang, we'll have all those resources for you in the description of the YouTube video below. I don't believe we have the examples there, but we'll get those added ASAP right
yes,
after
I'll
the
bring
call.
this back to you.
Yeah, beauty. Uh, so if you can get those scanned, I have one more QR code for everybody to scan once you're all done. In 3, 2, 1. All
Do you want
right.
to share your screen?
Not the screen, but
Oh,
bang, this QR code right here. So this QR code, I know we had a lot of QR codes. This QR code is for you to scan, those of you in the audience who were attendees today at DevNTell, for you to get your NFT for being an attendee today. So what you want to do is grab your regular QR code scanner, scan this bad boy, fill out the form, and you'll be airdropped a attendee NFT within the next couple of days for coming on the show with us today. And you'll have an hour and a half from right now to do that before the form closes. And with that, I just want to wish everybody a very happy Friday, happy weekend. Ben, thank you again for coming on the show. Really informative, interesting talk. I personally didn't know about Axelar Network before, but it seems like a very promising project that I'll be digging through and adding to my list of things to
yeah.
research.
One last shameless plug here. I just wanted to
Yeah,
show this off. We just hit our millionth transaction. I believe it was this week or maybe last week, but very recently we've had almost $7 billion in volume go through us. So it's a really exciting time to now to get into Axelar.
amazing. Congratulations. And yes, like I said, it looks really neat, and I'll definitely be researching it a bit more after today. Uh, and with that, yeah, again, just happy weekend, everybody. Happy Friday, and we'll catch you back here next week on DevNTell. See you again.
Thank you.
Peace.
Bye.